Good afternoon, everyone, and welcome to our in-house lecture series. Today we have Miss Alicia Lutchman, and Alicia Lutchman has been employed at the Bermudez Biscuit Company Limited for over 7 years and is currently the quality manager. She's an active member of the Food Science and Technology Industry Advisory Board in our Department of Chemical Engineering. Alicia recently completed her master's in science degree with distinction in food science and technology, and she graduated top of the class at the American Bakers Association, Washington, D.C., Advanced Cookie and Cracker Manufacturing course in 2018. She's a case study writer for the Institute of Food Technologists, IFT in Chicago, USA, Food Science for Relief and Development Program, which applies the study of food science and technology to enhance global food security, eliminate malnutrition, and grow sustainable economies in relief and development regions. Today, Ms. Alicia Lutchman will be presenting to us on selected quality attributes of a protein-rich cookie supplemented with soy flour, and her supervisor for this project is Dr. Sahida Mujaffer. All right, Alicia, over to you.
Okay, good afternoon, everyone, and thank you for that lovely, warm introduction. I am so glad that you all are joining me today as I go through my project, which is based on the selected quality attributes of a protein-rich cookie that has been supplemented with soybean flour. And this was done, again, under the oversight of Dr. Sahida Mujaffer. So on the agenda today, we'll be looking at the background and objectives of the study. We will look at the materials and methods, as well as results, conclusions and recommendations, and finally, references. Background and objectives. Cookies or biscuits are defined as a sweet, soft, or crisp product made from wheat flour, shortening, sugar, and baking powder. So in the Caribbean, we tend to use the word cookie and biscuit interchangeably. However, they are actually separate definitions. For example, in the US, cookies are considered baked sweet cookies like chocolate chip cookies. However, in countries like Australia or in the UK, they're actually considered biscuit and they prefer a more firmer cracker type product. So why is this relevant? Lately, the world cookie trend has been on the rise. Cookie consumption and demand has been growing rapidly with $76 billion market share in 2017, and it's expected to reach $110 billion in 2025. So what we have is like an overall net percent of 5% increase with each year in the cookie industry. And if you look at this graph, on my right, we have cookie growth in all categories. So we have bar cookies, molded cookies, roll cookies, drop cookies, and others. And one of the main drivers to this growth in cookie increase is actually the drive for healthier or higher protein cookies, protein with higher fiber and less sugar. So when we look at the high protein cookie trends, again, we have growth in all regions. The good thing about cookies is that they are known and loved globally. So it's a very good market. And we actually have had high protein cookies entering the market in 1993, which was done by Lenny and Larry's. And since then, we've had a lot of other players actually pick up on the high protein cookie trend. In 2023, high protein cookies were dominant more or less in the European markets, and they continue to grow, not only in the European markets, but wherever cookies are consumed. This brings us to the use of non-wheat flour in cookies. So cookies are an easy target or an easy carrier for enrichment as a snack, or it is also used as a food source. So when we think about increasing the nutritional content of cookies, it has to be done through non-wheat flours. So legumes have been identified as a great alternative. They are a rich source of protein, fat, minerals, and we have a lot of diversity in terms of edible legumes. As you can see here, they come in a variety of colors, flavors. We have lentils, peas, chickpeas, beans, soybeans, and proteins, which are very popular again, as we have vegan diets, or we have certain countries where we do have a lot of legumes being produced. So the legume flours are made from a simple process. Usually it includes boiling and drying of the beans, followed by milling. And the enrichment of cookies using legume flours, again, is an emerging trend, in particular for persons who would like to boost the protein content of a cookie or any other food. And the results would vary based on the type of legume flour used, as well as the percent substitution used in the formulation. Therefore, there is an opportunity to enhance cookies with the use of a legume flour. Soy flour was chosen as the best option to enhance the cookie because it is an excellent source of macronutrients. It also contains calcium, alpha-linoleic acid, magnesium, iron, sodium, zinc, and phosphorus. And what is interesting about soybeans is that they actually provide 2 essential fatty acids. So essential fatty acids mean that they are not synthesized by the body and it has to be consumed from the diet. So soy flour, it's originated from the soybean, which is considered an edible oil or an oil seed. So it's very rich in fat and those omega-3 and 6 fatty acids. So a lot of work has been done because of those great properties that soy flour present, and soy flour has been successfully applied to the substitution of wheat flour in levels of 20 to 50% in cookies, all having acceptable ranges in terms of the sensory evaluation parameters. So from the research, the cookies that are made with different substitutions of soy flour have shown increased levels of protein, fat, fiber, ash, and energy with decreased levels of carbohydrates. So as I mentioned, soybeans, they store energy as fat as opposed to as starch, which is the carbohydrate portion. And again, we also have some micronutrients there, sodium, magnesium, calcium, and potassium levels, which are very high in not only the flour, but whichever end product that you choose to use it in. The physical parameters of cookies baked using soy flour, they don't show much difference. So no significant trends were seen in the research in terms of things like cookie weight, spread ratio, and thickness. However, an increase in cookie strength is expected with increased soy flour because of the increased protein content. Levels of 60% and above have been deemed unfavorable based on results from sensory evaluations. Persons describe the substitutions above 60 as having a raw beanie or a grassy type flavor. So it's not advised to go above 50% when using substitutions of soy flour. In terms of microbial analysis and food safety, cookies generally have low total aerobic counts and no coliform and yeast or mold growths because the high heat treatment acts as a kill step. And when you combine this with hygienic manufacturing practices, it guarantees that your product has a long shelf life. So shelf life studies have been done using as much as up to 50% soy flour, and there was no substantial decrease in the sensory evaluation after 16 weeks. However, an increase in moisture content is expected because when cookies are baked, you are packaging it, you're not vacuum sealing it most of the time. So over time, the moisture level in the cookie would first migrate into other parts of the cookie. So it'll try to reach equilibrium. And then we also have moisture that is in the sealed air in the packaging material, which would also migrate into the cookies. So after the cookies bake and cool, you do have a certain level of moisture ingression happening, which of course, it comes with the deterioration of the product. For the objectives, with the main objective in mind to develop a protein-rich cookie supplemented with soybean flour, we had five specific objectives, which was to analyze and compare the properties of the soy flour, which would have been produced in-house, with commercial grade wheat flour, to analyze the dough properties using a 30% soy flour to wheat flour substitution, as well as to investigate the parameters of the baked cookies. So this would have been done via proximate analysis, physical-chemical analysis, as well as sensory and textural analysis of the cookies. Finally, a packaging and storage study was done using ambient warehouse conditions, and a preliminary cost analysis was done just to bring it back to the industry perspective. Materials and methods. The process steps were simple, just as you would bake a cookie at home. The ingredients were prepared and sourced locally, after which the mixing of the dough was done according to the standard formulation. The dough was then cut and baked. Afterwards, we had cooling and storage. So I will go through these a little more in detail here. The soy flour was produced in-house, and this was because we wanted the highest level of protein in the end cookie. So in the preliminary works, research would have been done looking at what was on the market in terms of already processed soy flour, what were the protein content, and we actually compared it to soy flour made in-house. So in the initial steps, different levels of, from the literature review, different studies use different methods to obtain different protein levels. And the study which produced the highest protein content from the soybean actually dehulled the beans. So when this was tested in a lab setting, it was actually higher in protein content than the commercial grade soy flour. So soybeans were therefore obtained from the local market, and they were washed 3 times to remove any foreign matter or any beans that, were not fit for use. After which they were soaked for about 30 minutes and then boiled for 25 minutes. After the boiling was the long hard task of manually dehulling the beans. So this just meant removing the seed coat or that outer portion of the bean and setting it aside. After which this process would have split the beans. So the split beans were placed to dry in a drying cabinet for 24 hours at 60 degrees C. At 60 degrees C before milling. So the milling was done in the lab as well, and it was ground to a fine particulate size, which was comparable with the wheat flour, and it gave a moisture content of 4.2%, which is acceptable for flours. After which, the cookie dough was prepared. This is a simple cookie formula, which is presented by the American Institute of Baking, was used as a base formula. However, various optimizations were done from the preliminary work. So in the aim of providing a protein-rich cookie and a somewhat healthier cookie, the sugar content was reduced by 50%. And of course, the flour was substituted with 30% soy flour. So the baker's percent calculation was used to calculate the formulation, develop the final formulation, which is a method generally used in the baking industry. So really, it's a mathematical method where instead of calculating the ingredients as an overall percentage, we actually divide each ingredient by the weight of the flour. So as you can see here, the cookie dough was prepared using a 2-stage mix. So the first stage would be the cream up stage, where the aim is really to more or less whip the first stage ingredients. So that would be a shortening, sugar, salt, and soda. You mix that in. After it's well incorporated and after it's well incorporated and of a uniform consistency, you then add your water and then you add the flour last. So as you can see here, I will talk about water absorption of the flour a little later on, but from this picture, you can see that the soy flour at the bottom is actually even a drier dough than the control, and it has to do with the water absorption of the soy flour. So after the preparation of the dough, the dough pieces were then rolled out and to form a sheet. And one of the things that is controlled by the industry is that they actually have automated machines which would sheet the dough. So usually we call them laminated machines, and they use automatic settings to adjust for the dough sheet thickness. However, while I was doing the preliminary study, there was an issue which, again, if not controlled in the industry, causes a lot of problems down the line, which was achieving a consistent dough consistency. So when I was just using the rolling pin, I could not get even measurements across the dough. And whenever I made adjustments, I either went lower or higher in terms of the dough piece weight. And why this is an issue in the industry is that you want to try as much as possible to have a uniform bake and consistency. However, if there are fluctuations from your dough piece weights and you're baking under the same conditions, you would have uneven color, you would also have uneven bake weights and uneven moisture percentages. So you really don't want to have any other variables when you're making it commercially, because something like an uneven moisture content could actually cause the staling of the product faster. It could be prone to spoilage organisms, as well as from a quality perspective. Persons might think that the lighter cookies are underbaked, or on the other end, the burnt ones, which would be darker in color. So a tool was developed to prevent this issue and actually to create a uniform consistency or a uniform thickness of the dough. So from the preliminary study, it was noted that the ideal thickness for the cookie before baking should be around 5.5 millimeters. So a piece of food grade steel was then taken and actually carved out so that the inner portion would give exactly 5.5 millimeters. So this tool was used to ensure that consistent sheets were not an issue. And this innovative tool could actually have a lot of applications in the kitchen at home, making cookies at home, making pizza at home to actually achieve the same effect. So after the rolling out of the cookies, they were then cut and dockered. So dockering is the method where we apply holes to the cookies. And again, this does a number of things. It prevents blisters from forming, which means it allows a more even bake, and it allows all those steam and gases to escape from the cookie, so you don't have blistering and hard surfaces forming at the top. So the cookies were baked for a total of 4 minutes at 375 degrees. Next, the cookies were cooled and then packaged and stored. So for the packaging and storage study, BOPP film, which is biaxially oriented polypropylene film, was used. This film is used in the baking industry. And so biaxially oriented actually means that during the process of manufacturing the film material is stretched in two directions. So at first it will be stretched in the direction of the machine, and then it is actually flipped and stretched in the opposite direction. What this does, it increases the toughness and stiffness of the film. It enhances the clarity, as well as it improves the oil and grease resistance. It also ensures that we have enhanced barrier properties to water vapor and oxygen. So this film could be used either in the clear format or the metallized version. The metallized version actually has an aluminum layer added to it. And what this does, it simply enhances the permeability of the film. Sorry, the addition of the aluminum layer gives a silvery effect to the film, which reduces its permeability to light, water, and oxygen. So again, we would want the packaging to ensure that the cookies actually do have a long shelf life. Analytical methods were used to analyze the flours. We would have looked at crude protein, gelatinization temperature, particle size, the bulk density, flour swallowing capacity, oil and absorption capacity, solubility, moisture, water, activity, TSS, color, and subjective evaluation. So I will look at this further in the results section. We would have also analyzed the dough parameters using a farinograph equivalent method with a dough lab analyzer, and also analyze the texture of the dough piece. Proximate analysis was done, where we would have calculated crude moisture percent, ash content, crude protein content, etc., as well as the physical and physical-chemical analysis of the cookies, which would have looked at parameters such as weight, thickness, diameter, spread ratio, texture, water activity, pH, salt, total soluble solids, and color. Also, an initial sensory evaluation of the cookies was done using a 10 semi-trained panel. They looked at a 9-point hedonic scale and basic subjective attributes of the cookie, which would have been color, aroma, texture, appearance, malt sensation, soy flavor, taste, sweetness, and overall acceptability. And an in-depth sensory evaluation was also done by a trained professional panel. So this panel would have done a 2-day sensory evaluation training with the Kerry group. They are the leader in sensory evaluations, and the Global Taste and Nutrition Company is more or less their logo. These persons would regularly participate in sensory evaluations done at my company. And with a trained panel like this, a boardroom style roundtable setting was done, which is suitable for discussions and vocabulary development. And we also did an individual assessment. However, all descriptors were discussed as a group at the end of the tasting session. And for both sensory evaluations, water, crackers, and coffee beans were provided as palate cleansers. And for the professional evaluation, we would have used soy milk samples and compare how the soy cookie flavor compared with the soy milk, because in the industry, soy milk is used as the standard for soy flavor and soy taste. Now on to the results. From the proximate analysis of the flours, the protein content for the soy flour, as expected, was a lot higher, and the carbohydrate content was lower because, again, the soy flour is storing energy as a fat, so the fat content was also higher. The moisture content of the soy flour was lower than the wheat flour, which is desirable for baked goods because you want to get that long shelf life study. The ash content was also higher for the soy flour because soybean has all those minerals and nutrients. And even though we dehulled the beans, we still actually had a higher crude fiber than the wheat flour. And of course, the energy value for soy flour was higher because we have a lot of oil stored there as energy. In terms of the physical and physical-chemical analysis of the flours, the soy flour had a higher gelatinization temperature, which really is a descriptor for us as those starch molecules begin to break down in the presence of water and heat. And the bulk density of the soy flour was also less than the wheat flour, which describes the level of compactness of the material. So it's based on the particle size. And what is good about an item with a low bulk density is that it requires less packaging material. The flour swallowing capacity as well was higher for the wheat flour in comparison to the soy flour, which really represents the ability of the granules to absorb water and swell. Thus, the water absorption and oil absorption capacities for the soy flour was higher. The water absorption for the soy flour was higher because we have a lot more protein available to actually bind with those water molecules. And similarly, for the oil absorption, we have a lot of those oil-loving or lipophilic sites where the oil could actually bond easily. In terms of the solubility, which represents the ease at which a material dissolves in aqueous solution or water, the wheat flour was found to dissolve more easily. And again, the soy flour, with all those fatty components, it was higher. The pH value of the soy flour was higher than the wheat flour. So it's actually closer to neutral, which is good for use in products. It means that it could actually increase the alkalinity of a product. And this is important for persons who have peptic ulcers or sensitive stomachs, and they really need to consume items within that neutral range or close to that neutral range. The water activity was also lower for soy flour. So again, it tells us that I could store my soy flour for longer. It's more stable, and I probably don't need as stringent storage conditions. Salt content of the soy flour was also more than the wheat flour, so it can contribute to your daily recommended amount of salt. The bricks content was higher than the wheat flour. Again, soy flour is much sweeter than wheat flour. And in terms of the color, the L-star reading tells us that the wheat flour is lighter in appearance than the soy flour. The A-star reading means that the soy flour had more of a reddish tinge compared to the wheat flour, which we know is off-white. And our B-star value, the soy flour, is much more yellow in comparison to the wheat flour. In terms of the actual granulation size, I have this picture here. It tells us that the soy flour was a little larger than the wheat flour. So the wheat flour, most of it would have passed through the 0.85 mm sieve, compared to the soy flour, where most of the soy flour would have passed through the 0.6 mm sieve. Next, farinograph results were done. So a farinograph is a tool used to assess the baking qualities and performance of wheat flour doughs. It would mix the dough and record the resistance to deformation, the consistency of the dough as well. So how farinographs work, they would actually take a standard size of flour, for example, 300 grams, and it will automatically add the water. So any farinograph method, you have to mix the dough and you have to manually add the water drip by drip as it develops. However, the method used is a newer and electronic version where it will automatically dispense the water into the dough as the dough develops. So using the Perton Dough Lab Analyzer, the AACC International method was still used to analyze the wheat flour and 50% soy flour sample. However, we would have had that automatic dispensing of the water. So this is what a typical farinograph would look like. It measures the strength of the flour by looking at different parameters on the graph. So for example, the water absorption would tell us the amount of water it took to actually balance the the graph on the 500 unit line. So the graph is very useful in terms of the information it gives us would indicate the strength of the flour. So for example, the peak farinagraph unit would be a recording of the highest torque that was used whilst developing the dough. So from this table here, the soy flour value was much higher than the wheat flour value, which meant that it took a lot more force and motion to actually develop the dough. Stability time is the difference between the arrival time and department time, which really means the time that the graph reaches the 500 unit line till the time it falls off the 500 unit line. So the longer a flour is able to hold that 500 line, the stronger the flour is. So we would have seen that the stability time for the wheat flour was 3 minutes. However, for the soy flour, it was almost double at 6.2 minutes. The development time is the time taken to actually mix the dough from the start of mixing till when it reaches the peak value. So it also tells us, again, how much energy is really needed to develop the dough. And the departure time, it tells us how long the dough could resist over mixing. So for example, if I'm mixing a cookie with 100% wheat flour, I know that all I need to develop the gluten is 3 minutes of mix time. And if I go over that, I'm actually starting to break down the gluten structure by over mixing. So it shows us that the soy flour could withstand a longer and a more rigorous mix time. Right? So those were the high.
Sorry to cut you. You have about 5 minutes left. Right?
Okay, sure. So those with a high stability and high absorption are superior for industry because they could withstand machinability. And we also have higher yield economics because of the higher water absorption. It means that I could actually get a greater yield from the same amount of raw material. And the mix intolerance index means, or it tells us how quickly the flour breaks down after development. In terms of the dough properties, the dough hardness, adhesiveness, and resilience were measured. And again, it was found that the soy flour was higher in all values in comparison to the wheat flour. And this is most likely due to the fat coating effect that the high level of lipids has on the development of the gluten protein, as well as the water absorption of the soy flour. So in terms of the physical and physicochemical properties of the cookies, there were no significant differences in the actual physical parameters, such as weight, thickness, diameter, and spread ratio. However, we saw increases in the saturation capacity, which again has to do with the level of water absorption. The water activity was lower for soy flour cookies based on the lower water activity of the soy flour itself. And again, we had an increase in the pH of the product, since the addition of the soy flour would have helped bring it into a more neutral range. And of course, the total soluble solids content was higher because the soy flour is so much sweeter than the wheat flour. So in terms of the proximate analysis of the cookies, of course, we had a huge increase in the protein content from 5.84 in the wheat flour to 15.15 in the soy flour. We also had an increase in the fat content, and again, decrease in moisture, increase in ash, and increase in crude fiber, again, due to the constituents of the soy flour. For the sensory analysis, there was a great preference for the soy flour in comparison to the wheat flour cookie. The panelists preferred the soy flour because they liked the light brown to golden brown appearance. as well as the enhanced cookie taste, the flavor and aroma with the addition of soy. So I will go into that a little more. The appearance, the wheat flour cookie had some white specks in comparison to a nice consistent golden brown color in the soy flour cookie, as well as the aroma. We had a nice pleasant baked soy flavor and aroma in the soy flour cookies. The texture of the soy flour cookies were also preferred because, again, it was lower in moisture, so we had a more of a firm, crisp crack with that first bite. And the difference in flour particle size actually gave the soy flour cookie a nice digestive type, oatmeal type flavor or mouthfeel that panelists associated with a healthier cookie. The soy flour also had a sweet, more gritty aftertaste, which panelists found was pleasant. From the storage analysis results, the soy flour cookie and the wheat flour cookie both performed well during a 60-day trial. And it was found, though, that, again, the metallized film outperformed the clear film, again, because of that reflective property, which reduces exposure to light, oxygen, and water. From the storage analysis as well, we would have started off with all cookies having a moisture range between 2.54 to 2.84, which is typical of cookies. And during the 60-day period, it would have increased to 3.71 to 3.31, which again is acceptable. And we could probably even continue to run this storage study for another 60 days and reevaluate. The initial water activity also increased from 0.31 to 0.38, and it was still, however, within acceptable limits to guarantee us of safe food. So in terms of the nutritional values of the cookie, you actually only need to consume 67 grams of the soy flour cookie to get 10 grams of protein. And 10 grams of protein is all that is needed to make a health claim for a high protein food, because the daily recommended allowance is 50 grams. And once you're able to supply at least 20% of the recommended daily allowance, you're allowed to make that claim. And this is in comparison to having to consume 172 grams of the wheat flour cookie. So this 785 calories is actually equivalent to a meal like roast pork and potatoes or rice, lentils, and chicken. So actually think about the amount of cookies you'll have to consume to just get that 10% protein compared to the soy protein. And because of that, it's actually more feasible to produce a soy flour cookie. In addition to the soy flour being cheaper than the wheat flour, you actually need to produce less to get that same nutritional value. So it is both profitable for the manufacturer, as well as it could be set at an attractive price point for the customer. So in summary, the addition of soy flour has proven to have a strengthening effect on the dough, which ensures good manufacture machinability in the industry, as well as an increased yield. And the addition of 30% soy flour can increase the protein content of cookies to actually give you that 10% required. And in addition to that, you also have the healthy increase in fats, fiber, ash, and energy content. And soy flour cookies are actually preferred by panelists due to enhanced flavor, aroma, color, and texture. So in conclusion, cookies produced with 30% soy flour are not only organoleptically and nutritionally superior in comparison to wheat flour cookies, but they could actually provide protein, essential micro and macronutrients, as well as a healthy level of fats. And it's a great opportunity for industry application given the current global market trends and the potential that cookies have to play in all regions. So next steps or recommendations for scaling up would be to ensure that it is profitable by doing a further study in terms of the costing. So the costing I would have done would not have included overhead costs such as labor, etc., to run on the line. Actually doing a line trial. So the line trial will help confirm those costs for us, which is the labor required, the overhead, the line speed, and the product output. Ensuring that you do a process validation study for the kill step to ensure that the bake time and temperature is adequate. Doing quality control checks, conducting an official shelf life study to determine your maximum shelf life, and completing a wider sensory evaluation study. So that brings us to the end of my presentation. Thank you very much. Do we have any questions?
Thanks, Alicia. So we have about 5 minutes for questions. So I open the floor up quickly for anyone who has any questions for Alicia.
Thanks, Therese. Excellent presentation, Alicia. This is Rafi Hussein.
Thank you.
Does drying condition or method of drying affect the nutritional value?
From the research I have seen, not quite so much. To me, it's more of how it affects the milling or the grinding of it, because in the preliminary study, I would have tried a shorter drying time, same temperature, but I had a lot of issues with it sticking up while I was grinding. So I went back to the 24 hours by 60. But I would have also seen some persons dry at higher temperatures. So I saw as much as 85 degrees C, but I didn't see that it greatly impacted the protein content.
Okay, thank you.
Sure, you're welcome. Anything else?
Any other questions for Alicia? Okay, I actually have
a quick question.
Oh, sorry, Cedar. Yeah, go ahead, Cedar.
Okay, so Alicia, you mentioned the labor involved in dehulling the soybeans. So that, would there be an industry solution for that if you had to scale up, for example? Or are you just going to? Yeah.
I actually saw what they did. They have commercial type mills that dehull as part of the process. So again, it involves the soaking, but you run it over these rolls. So it kind of dehulls, and then you trim off that waste, and you then proceed with the dehulled.
Very good, very good. I think that's my only question at this time. Very good presentation. I enjoyed it.
Thank you.
Thanks, Sahida, and thanks for stealing my question. That was actually my question.
Anytime.
I was going to ask if there was some kind of machine or device you could use to do the
I saw persons on YouTube using a blender at home to do it.
Okay.
But you're not blending, you're just pulsing for like a few seconds. I did try that, but it didn't work as well as me sitting there with my hands dehulling.
Yeah, that seems a bit risky in terms of if you just pulse a little too much, you don't get the effect.
Yeah, and then it was damaging the soy beans itself.
Oh no. Yeah. The things we see online sometimes they just don't work in real.
Yeah, exactly.
Reality versus online. Also, a comment, because I don't know how many of you all would have seen that they are currently harvesting soybeans in Guyana from their trials, so that in the region we will actually be able to have a supply of soybeans, which I think is a really good positive move.
Yeah, true.
That's interesting. Alicia, compared to, so I know you compared the wheat flour protein cookie to the soy flour protein cookie. In terms of the content, so you see, I noticed, like, for example, the fat content is higher as expected from the soy. Do you think this would put off people, like, those bodybuilders and people who go after those protein cookies? Do you think that'll be a deterrent or not?
Yeah, I think as someone from the industry, we do have a responsibility to educate the consumers, because there's a lot of misinformation out there, that persons easily they get caught up in, the big trend like gluten-free or whatever is happening, keto diets, etc. So I think with the right marketing campaign, you could actually get a lot of benefits because you have the essential fatty acids and you have all of the nutrients that could actually help the bodybuilders, because in addition to having essential fatty acids, we also have in the soy cookie that high fat content, which helps to make the other fat soluble vitamins like vitamin E, D, E, K, etc. So it will actually help them in the long run.
Oh, nice. I like that. I really enjoyed your
Yeah.
presentation, Alicia. It was very well done and very informative. I look forward to seeing more of this. Hopefully we could see one on the shelves soon.
Yeah.
How long you think? Yeah, hopefully soon we could see this. It'll be nice to see something being made locally, especially as Cedar said, if we could get the beans from Ghana and get this going, that'll be very nice to see. So we're out of time, Alicia, but thank you so much for your wonderful presentation. And I want to thank all of you all for attending. This is our last presentation for the semester. We ended off in a bang. Thanks, Alicia. So all the best for the rest of the year, and I wish you all the best for the new year, but we'll see you all next year. Thanks so much for attending, Alicia. Thanks for taking the time to do this presentation for us.
Thank you. Thank you for listening to me and allowing me to share my presentation and my findings with you guys.
Yes, we probably have you back soon. You never know.
Nice.
All right. Take care, everyone. Bye. Stay safe.